3, 2, 1.
Hit it! Experience 24 hours of head-to-head AWS sessions from around the world.
Mic check, 1, 2.
Jaws PANKRATION 2021. Up till down.
皆さん、こんにちは。私の名前はブルック・ジャミソンで、オーストラリアのブリスベンから来ました。今日はコロナ時代の職場の安全のための人工知能コンピュータビジョンについて発表します。Hello everyone and welcome to Amazon Rekognition COVID-19 edition, all about artificial intelligence and machine learning computer vision for workplace safety. My name is Brooke Jamieson. I'm the head of enablement for AI, machine learning and data at Blackbook AI, and I'm also an AWS community builder for machine learning, and I'm so excited to be talking to you today. So I'm from Brisbane in Australia. And I would like to start this off by acknowledging the traditional owners of the land that I'm broadcasting from today, the Yagara and Turrbal people, and I would like to acknowledge the elders past and present. This is something that's really important to Australians, that we always acknowledge the traditional custodians of the land, and I'm really excited to share that with you today. Additionally, I'm so sorry, but I don't speak Japanese. I will make subtitles for this that will be above or below translating this for you, so hopefully that helps. And I've made a tutorial previously for how I make my subtitles for my videos if you would like to learn more about that. And as well, so I'm from Blackbook AI, which is an Australian consulting company with over 150 staff in Brisbane, Sydney and Melbourne. And we specialize in artificial intelligence, machine learning, robotic process automation, data ops, and full stack digital development. This is some of the team that I work with, and hopefully we'll all get to meet you. Today, I'm going to be talking about Amazon Rekognition, which is an AWS service that helps you to automate your image and video analysis with machine learning. With Amazon Rekognition, you can quickly add pre-trained or customizable computer vision APIs to your applications without building the machine learning models or infrastructure from scratch. So you can make the most of what's already been built, and you can then customize that for your needs. So it's so much faster to iterate and improve and get something that's perfect for your application. You can also augment human visual review tasks with artificial intelligence, which is really important for enterprise scale and really large enterprise applications that really need that human review process. But this helps you to either automate that or just augment it with AI as well. And like all AWS services, you can scale up or down based on your business needs, and you can only pay for the images and videos you actually analyze. So this is in tune with everything about AWS. And now I'll go through some of the different use cases for Amazon Rekognition. There's a number of small products that make up Amazon Rekognition, and I'll go through them all, but then the one at the end is what we'll be talking about. So there's everything from content moderation, making sure content is safe for family or business purposes, face searching and comparison, as well as face detection and analytics. You can also do image and video labeling with inbuilt models, or you can use custom labels for images or videos, which, as you can see in this image, is helpful if you're trying to find a specific logo as part of a broadcast package or something like that. And you can also use text detection on images and videos, even if it looks a bit different. It's quite good at picking things up. And you can use celebrity recognition. This is one of my favorite AWS products, but you can scan images or videos to find celebrities in them. As you can see, it's picked up one of Vogel's here with the confidence level. I keep hoping that if I set the confidence level low enough, I will come up as a celebrity, but that's yet to happen yet. And you can also do video segment detection, which doesn't sound that interesting, but if you work in the media space, this is something that's really, really helpful. And separate to all of the features we've talked about, the personal protective equipment or PPE detection feature of Amazon Rekognition is really helpful. And this was mainly developed for normal workplace health and safety, but during coronavirus, being able to detect face masks is really important. So that's what I'll be talking about today, and it's what lots of businesses have been leveraging. So Amazon Rekognition Workplace Safety. Amazon Rekognition PPE detection uses machine learning computer vision to analyze images and detect PPE automatically. Insights from this system can be used in a workplace to help keep everyone safe by making sure everyone is wearing their face mask correctly. Over time, data can be used to find historical trends or patterns and find out how to create the safest workplace possible and improve the quality of management reporting. Usually everyone wants to wear their PPE correctly, but they just might forget. So being able to see if you are wearing it and then if it's being worn correctly over your nose will really help to keep each employee safe, but then it'll help them to keep their co-workers safe as well. Because especially in times of coronavirus, this is especially important. And now that people are good at wearing PPE, it's great to continue that as well as we move forward. So some features of the Rekognition workplace safety detection. You can get a quick summary per image. So as you can see here, it will give you a bounding box around the key PPE items in the image, but it will also give you the confidence level of the model for each of those bounding boxes as well. You can see the PPE worn prediction. So it's not just that it's detecting a face mask in the image, but it will also detect if that's being worn correctly over the nose, for example, and also for the other PPE that it can detect. And you can see per person details. So if there's an image with 4 different workers in an image, you can see for each person in the image what PPE they're all wearing. So it's quite granular, which is really helpful, but it doesn't recognize any of the faces. It's just detecting them. So people's privacy is still maintained. And you can also do custom PPE detection. So the head covering or a helmet and the face mask or a face covering or the hand covering or gloves are included as standard, but you can customize this to add if there's a specific high-vis vest you need to wear, or maybe you need to wear a mask and a face shield. Whatever it is for your organization, you can customize this into the model so it's something that really grows with you over time. And now we can try Amazon Rekognition PPE detection through the console. So I'll go into that demo now. This is a really handy link because you don't actually have to do the service. It just shows it for you. So this is a sample image like what you've seen. And what it's showing you here is what the interface can look like for this demo. And so you can see if you would like to have required PPE, it includes the hand cover and head cover, as well as the required minimum confidence level. And then it gives you the person breakdown of each item or PPE object that's detected in the image, as well as the confidence level associated with that. And in addition to this as well, you get the request, which shows you the JSON of how that's presented to you normally. And you can also see the sample response as well. So this gives you the same results that are on the demo, just in a way that you can work with programmatically instead, which is really helpful. I really hope you get some time to play with this demonstration yourself, because I'll go through a few examples in just a moment, but I think it's always good to try out. So now I'll just change the language over to Japanese, so hopefully it's a little bit easier to follow. So now what we're doing is looking at the same sample image, but hopefully now it's a little bit easier for you to see what's going on. And you can see here, this is if you would like to change the confidence level to maybe make that higher or lower. 80% is standard. And this shows you the required PPE. Now we can go up and see the people with required equipment. So it says 0 there, but it starts counting from 0. So that actually means 1 person. It will also count if they're not sure about people or if they know someone isn't wearing the required PPE. And this section will detect all of the metadata on that person. So it will show if they've detected a face cover and if they've detected it on their nose, and you can see the confidence level. But even though we've only set the face cover as required, it will go through for everything that's detected in the image, which is really helpful. And you can see the request and the response like before. So this now is if you would like to make other things required. So you can now see if they've gotten everything that's required of them as part of that count at the top. And now we'll click over to the other sample image that has 4 different people in it. So now you can see the per person breakdown as well. That's really important, but it's going through and it's still giving you the bounding box for each object detected on each image. And now you can see how those totals will change for people with and without the required equipment, because they don't have hand coverings on, so now they don't have all of the required equipment. Once again, it starts counting at 0, so 0, 1, 2, 3 actually means 4 people. And this is per person breakdown, so you can really click through to see a breakdown of all that metadata with the different confidence levels for each person detected in the frame. And now I'll go through and I'm adding some of my own photos that I took briefly in the office before to help you understand what's really going on. I'm just fetching those in the background now. So this is a photo of me in my office. I'm wearing a face mask. So it's great that it's detected I'm a person. That's very reassuring. And it's also detected with really high confidence that I have a face cover on and that's covering my nose. So now I tried to trick the algorithm a little bit. So I tried to see if I covered it with my hair. See here how it's not quite sure, it's indeterminate. So it still knows I'm a person, but it's really not sure if I am actually wearing a face mask because that's below the threshold to be reported on. And I keep trying different things to see how much I can fool it. I don't know about you, I always try this with demos. And see now it's 50% sure that the face mask is on my nose, which is reassuring because it actually is covering my nose. So it's quite a good guess considering it can't actually see. And also I'm obscuring my eyes as well, so it would have been harder for the model. This one here it's 80% sure it's not on my nose, but it actually is under all of my hair. I don't think the model was trained for this, so I don't blame it for not getting it wrong, but hopefully in a workplace people don't have their hair down like this if it's unsafe. This is interesting because I wanted to see what it would do if I was holding my face mask down rather than pulling it underneath my nose like people would normally have if they weren't wearing their mask, just to see what the model was ready for. But it's really reassuring that it's still detecting my face and the face cover quite well. It's just not sure if it's on my nose correctly or not. And so this thinks that the face mask is covering my nose, which it almost is, I guess. It's just at the tip of my nose, maybe if I had a really long nose. And it's detecting my head as well. And I just wanted to see what would happen if I took different photos. And this one, it isn't even detecting the face mask at all because it can't recognize it on the side of my head. And even if I turn the confidence level way down, it's still not showing me in that response part. So always play around with this and make sure it is actually relevant for your corporate use case. I think I really am giving it some very weird edge cases that you wouldn't really encounter normally. So don't be worried if this isn't showing up how you would want. I think really try it with some frames from your own CCTV footage if you're going to export stills. And then you'd be able to see how it's going to deal with things if you're really not sure. Because you might have lots of situations like this where it's just really straightforward, especially if you're taking these images before someone enters a space, for example. And then as you can see, because there was lots of data collected, the request and response are quite detailed here, including those confidence levels, which is really helpful if you'd like to integrate that into other features. And if you'd like to extend things and try to implement this solution for yourself, I really recommend this GitHub repository. The repo includes information about the service as well as a demo, Python samples for different use cases of the Rekognition Detect PPE operation, and information about the Amazon Rekognition Detect Protective Equipment API. This demo shows you how you can have a serverless architecture to process frames from cameras for PPE detection, and the demo application is deployed as an AWS CloudFormation template. This solution includes a web app that uses a webcam to extract frames and send them to an AWS API gateway. The API gateway then calls an AWS Lambda that interacts with Amazon Rekognition and calls the Detect Protective Equipment endpoint. When any protective equipment is detected, the UI interface shows the equipment name, its confidence level, and whether it covers the body part or not. Optionally, it's also possible to configure an Amazon SNS or Simple Notification Service topic to allow subscribers to be notified of any detection. Thanks so much for having me today. I've really enjoyed the time I've been able to spend on holiday in Japan previously, and I really hope I'll be able to travel again soon. Hopefully I can meet you all at another user group event when I get to visit again. If you have any questions, feel free to comment on my LinkedIn or Twitter and let me know if you have anything you'd like me to help with. And in addition, I write lots of articles about AWS on my Dev2 account, so it'd be great to see you there as well. Thanks so much for coming to my session about Amazon Rekognition COVID-19 edition, all about artificial intelligence and machine learning computer vision for workplace safety. Thank you so much for being patient with me not knowing Japanese, and it's been really great to see you all. See you next time.
Music's loud and I'm feeling alright. In slow motion, but it's just you and I. Yet the burn makes you feel so alive. I'm living the moment to the